It's all about the money. Gotta make that money.
Yeah, it's still part of the same. The middle 90 bounded on both sides. The middle 90.
Yeah, I mean,
Here's the middle 91%.
all right, guys, here's the answer for that 4A. You guys get that? 2843? So you make 27.2 minutes into a z-score first. We know it's normally distributed, so we can use the z-score chart to get any answer I want to, as long as I first get z-scores. Kind of makes sense. Z-score chart needs z-scores. So I make it into a z-score, I round it, and then I look it up, and you get 0.2843. Why don't I do 1 minus? Because I want below, and that's what the chart tells me. It's only when I want above that I got to adjust it, unless you like the shortcut. Okay. More than 53. Okay, so I'm interested in 53. Where is 53? Up here. More than 53. Now, which way am I going to shade from that?
Right.
So I want that little tiny area. So that's another reason why I want you guys to draw the picture. I already know if I get an answer like 0.8, does that sound right? That means 80% of the picture is in that little tiny, no, that tail ain't that big, right? It's a little tiny tail. You call that tail?
Let's go.
So whatever I look up and get, I got to do 1 minus that to get above there. So what's the very first thing I got to do here, though?
You got a 53?
Yeah, I got to make that into a z-score.
Yeah. 53 minus divided by 7. And you get 9967. 0.9967.
Now here's, let me make this really clear. Your calculator knows order of operations, which sounds great, but it means you put garbage in, it's going to spit garbage back out at you. If I put in there this, I'm not picking on anybody, by the way. I'm just saying this happens a lot. If I put this in there, why is it not going to give you the right answer? Yeah, it's going to divide first, and then, oh shit, I got to tell it. The poor little calculator doesn't have eyeballs.
You got to put parentheses.
Exactly. When we write something like this, there's understood parentheses, because that bar makes the top separate from the bottom. So poor little calculator, thank God it didn't have eyeballs. The TI 2000 will, and then it's guided, and then it's the end of everything. So. Oh yeah, I got you. So here we go, 53, you can do it that way if you want to. Divided by 7.81, so we get 2.73. Is that cool, guys? 2.73, which makes sense because it's up here.
And then you get 0.9967.
Yeah, so when I look up 2.73, you get what again?
0.967. 0.967.
Let's try this.
I'm never wrong.
9968.
Oh,
Does that mean the?
I was kind of wrong.
What does that mean? If you're never wrong, and that's the answer, I don't know what that's a paradox.
That's the first time I'm wrong.
9968. I don't know. Now, guys, you do not round that to 1, right? You don't. Please understand. That ain't 100%, right? We're going to 4 places, so it's it's not 1 until you got like 0.99999, and then you can basically say, well, that's almost 1. So of course that's not the answer. My answer is this. So what do I get for that? 0, 0, 3, 3.
Would it be 0.996?
Say again?
Wouldn't it be 0.999?
Why?
Let's
No, it's 2.73.
Why is it 2.73, not 2.74?
It's 2.73. How do you get 2.74 out of that?
Oh, 2.73.
No, you can't round this piece and then round this based on your rounded number. No. Is this 2007? Is that closer to 2735 or 2730? I'm sorry, going too far. Is it closer to 273 or closer to 274? It's closer to 273. This is not over 50. And just because you round it doesn't make it over 50. You just made it look like it was 50. What is it really? It's this. So don't start rounding way the hell down here and go domino effect. No. I want to round this place. What's the next number? 4. So I round this to 2.73. You're not allowed to go, let me change this, and that changes this, and that changes this, and that. No. Stop that. Okay. Is everybody cool with that problem now? 2.73. Is that all right? You guys can secretly hate me as much as you want to, as long as you do it right. Well, what would the percentage be here? Yeah, 0.32%. You want to write it as a percentage? Yes, ma'am.
I'm a little confused. Okay, I know how to get to 2.73 and then what do you do the rest of them?
All right, so once we get a z-score and I want to get a probability, I can then use the z-score chart. Look at 2.73 and you get 0.9968, right? That's the area below, automatically, because it came from the chart. The chart can only tell me areas below. But the question, what's the area more than? So we had to do 1 minus that to get the other side.
So you just subtract 1 minus.
1 minus that to get the other side. All right, so this guy, the mean is still 31.64. So 15.5 and 19.5 are both over there. My answer will definitely be less than 50%, for example, right? Or a little thing got all messed up.
Oh no.
So I got to change both of these to z-scores. All right, let's see if we can do this without controversy. What do you guys get for the z-score? 15.5. I heard a lot of different numbers.
Negative 1.55. You're talking about the first z-score?
Oh, it's 7.81. There you go. I can't even do it without my own controversy. So I get negative 2.07. Look at all this weird shit. Negative 2.07.
For 15 minutes?
15 and a half, yeah. And for 19 and a half, what do you get?
Negative 1.55.
Yeah. So that's the two z-scores I'm working with. Again, you never subtract z-scores because that makes you somewhere else than where you're supposed to be.
You can't just round it to 1.6.
Why don't I round it to 1.6? Because the chart goes to 2 decimal places. So it can be better than that. We can't be as good as 3 places, but thank God they didn't make this like 3-dimensional chart that went to the 3rd decimal. Here, here, here. That would be neat. All right. So we only go 2 decimal places. Now I look at the areas related to these two. What's the area below negative 2.07? 0.0192, I like it. And that is the 15.5, so that's negative 2.07. That's going to be 0.0192. And the area below negative 1.55,
0.06. I mean 0.0606.
1.55,
0606.
0606, I like it. 0606. Now you just got to do what with those? subtract those. So like, don't give me two answers to this question. It's one question and one answer. So when you subtract those, you get what? Sorry?
0.0414.
0.0414. I like it. I like it. Good job. So that is very much like this problem, 1C. We just had to make z-scores first, and then it was just like this problem. And now the last problem on this thing. Max and Tyler, put somebody in the 14th percentile. Where would that 14th percentile be?
To the left.
Oh, sure. Sure. So the 14th percentile would be somewhere down here. Is that cool?
Yeah.
Because it's got to have only 14% below it, so that's 0.14.
You find that on the chart, right?
Yeah, so if I look that up on the chart,
Negative 1.08.
yeah, you get really close to it. 1401. So you just get as close as you can. It's not a Price is Right game. You don't have to without going over. No? Yes. So you get negative 1.08. I like it. Now the question, is that the answer?
No, that's a z-score.
That's the z-score. And I want to convert that back into a time, right? We actually developed a formula for that.
So you solve for x.
Yeah. Remember this guy? So that's the analog to this guy. If I know all this, I can make a z-score. If I know all this, I can make a raw score. Yes, yes, sir.
I did it by putting in.
Yeah, you could use the z-score formula and then you're going to solve for x. I'd rather use a formula that's already solved for x.
Oh, okay.
Does that make sense?
You can still use the other one, right?
Of course.
So you don't have to memorize the formulas.
You don't have to memorize formulas in general with me anyway.
Oh,
Some, but not all of them. Right?
They're
Okay.
basically the same ones, right?
Yes, they are the same formula, just reworked. Which is why you learned that skill in algebra, because it's actually a very useful skill. I still don't believe it, but it's alright. I'll make you do what's good for you. So x equals, the mean was,
23.1.
no,
Oh.
mean was 31.64. And the z-score is negative, so I want to go down 1.08 steps, and every step is 7.81 bit. So if I start the mean and go down 1.08 of those, I'll end up at the 14th percentile. I'll end up at the time that's got 14% below it. In this case, is that a good place to be? 14th percentile.
Where'd you get the point away from?
So again, that was,
Yeah.
that's a good.
I'm trying to be 14% of the time. I'm trying to look at the market.
Find 14% in here, right? Because it's a percentage. 14th percentile is 14%. What's the closest I can get to 14%? 1401. Right there. Don't look at 0.14 over here. It's not a z-score. It's an area. There's 14.01. That's the closest to 14% I can get. And what z-score is that? Negative 1.08. There it is. See?
I'll ask you.
Okay. That'll work. And so what do you get here?
23.21
23.21?
minutes. It's minutes, right?
Exactly.
That's too long.
This is for a week. This is a week's worth.
I'm trying to have the exclusive part.
Well, you can try to have a lot of things. You got to accept that you just won't.
Money talk.
It's like your exclusive bathroom. That ain't going to happen here. Yes. No. What? That's standard deviation. Yeah.
Things taste like one.
Oh.
handout, all the previous answers, you have like time, whatever, 22, don't leave that on them. You have to rounds where like the other like basic studies and data values and things, you mark off things that are 22.
Oh, yeah, that's fine. That's fine. Yeah. All right, guys. So, any questions on that handout before we get to the next thing? Yeah, don't be sound like that. Do I got time? Oh, yeah, I do. Yes. Oh, wait. You got a question? What's up? Yes, yes. Just like practice test 1, I gave you an answer key for that, right?
Yeah, you said on Tuesday.
I wouldn't set you up, give you a practice test and no answer key this time. I'm not that evil yet. Yeah, we'll get a practice. You'll get the answer key on Tuesday. Test is Wednesday.
Yes.
Of course it will be. Yeah. And so will this stuff. What is it? What? Of course it is. Huh? Yes. You do see there's a whole other side there, right? Yeah. That's all right. Okay. Oh my God. I love these guys. All right, guys, last idea for the day. We'll finish this up on Tuesday. It's kind of a neat one. So remember I said, hopefully it really makes sense. This chart is a bunch of answers, right? I can only use it, though, if I have a normal distribution. If I don't have a normal distribution, oh, shit. Okay. So, chapter 7 is all about... Actually, chapter 7 is about a certain situation where if I meet certain requirements, I know I end up with a normal enough distribution. But the idea behind chapter 7 is this. Every single problem we just did, how many people was I talking about at that moment? If we randomly pick one student. Now, that doesn't make any of this invalid, by the way, but what do we normally do in statistics? We take a sample. And then I could say, is my sample that I just took, is that weird or not? I want to do something like this to figure out if it's weird, right? What's the probability that the sample I just took would have the average it does? So just, for example, I go somewhere and say, look at the percentage of people that got cancer in this little area. Is that weird compared to a sample I could take anywhere else? So here, this is taking one person and comparing them to the distribution of all other individuals to see where they are, right? In general, I want to take a sample of things and compare them to all the other samples of things. Okay? Does that by itself make some sense? What do we normally do in statistics? We normally work with a sample, right? So sort of like if I wanted to, if I felt that, just to make this really easy, I think I said something about this earlier this semester. I want to go find somebody, a good lumber place, and I want them to be able to cut their lumber to within so much. So let's say that there's one lumber place says, yeah, we cut to an average of, we can do like an average of 40 inches, no problem, with a standard deviation of whatever. And I want to check to see if they're telling the truth. If I take one piece of lumber and its length is 40.8, is that proof that the mean isn't really 40? If I take one piece of lumber, is that good enough? No. So I need to develop something that's not going to be too different from this. Don't freak out. This is going to take a while to talk about, but the end result is not going to be very different from this at all. Some of you guys are like, I wish it was, but if you do enough of this, it becomes not that bad. It really isn't. It's very recipe-ish. So the main thing that's going to happen, let's talk about what's the main thing to expect to happen. I want to lay some groundwork down, and then Tuesday we'll finish this up. I like to do this example. I can't remember if I've done this one yet or not. If I go to an alternate universe, Florida, where and then I start and I ask people, how old are you? And I plot the age. So I say, how old are you? And they say, I'm 2. And how old are you? I'm 88. You know, so, and then I make a picture. So what this would mean is this is some weird take on Logan's Run, maybe. There's just nobody in the middle. Right? So once these people hit that age, I kill them. And these are people that came from somewhere else. Like, I don't know. Screw it. Just this is how it turns out. You with me? So where's the average age, roughly? Look at it. It's going to be right in here, right? Okay, I like it. So this, now, how did I make this? I asked you, how old are you? And I put a dot. How old are you? I put a dot. How old are you? I put a dot. How old are you? I put a dot. So what's the most common age? Looks to be this. Around in here, and the next one would be there. Is everybody understanding what this represents? So instead, if I were instead of asking everybody how old they are and putting a point there, what if I were to take a group of 10 people and say, figure out your average age and tell me, right? So instead of saying, how old are you, put a dot. I take 10 people and I say, figure out your average age, and then I'll put a dot where your average age is. So the picture will now have average ages, not just individual people, but groups' averages. What's the most likely thing to happen? Is it most likely that I'll get a bunch of little babies? How old are you? Figure out your average there. You 2-month and 5-month-old kids. If I figure out their average, is it most likely they're going to have a bunch of people down here? What's the most likely thing to happen?
Slightly right of the mean.
Yeah, but why? What's the most likely? Am I more likely to get really old people? Am I more likely to get really young people? Am I more likely to get a bunch of people that are right here? What's most likely going to happen? A mixture of everybody, right? So the most likely thing to happen is I just get a mixture of both. In fact, any group of 10 people I pick, I would expect their average to be close to the actual average, right? Okay, so if I draw, so this is for individuals. If I now do groups of size 10, it's probably going to look something more like this. The highest peak will be right at this. Whereas before there was no individuals in there, now there's going to be most of the groups are going to be close to that. Just think about it. Right? Is there anybody in this group that's aged exactly at the mean? No. But if I take a sample of size 10, their average should be close to the actual average. Period. So it's probably going to end up looking a little bit like this. Right? A peak here and a peak there and then a big old peak there. Because most of the groups should be close to the real average. Now what changed? In fact, let me put a little bit different symbol here. This isn't just the pure mean. This is the mean of all the sample means. If I take a group of 10 of you and then another group of 10 and another group of 10 and another group of 10, and then I average all those averages, I'm still going to get the same stupid average that I would have if I did everybody one at a time. That doesn't change, yes?
With that though, if the kind of the peak of the older ages is slightly higher, as you're expecting to get slightly more of them than the younger ones, when you do the group thing, would the mean not shift slightly higher? Just because you're
Think about it, that mean has already shifted because of that.
Oh, guys, I'm looking
Okay,
at like
okay.
in the middle. Got it.
All right, so very decent. Let me say this again. If I took everybody individually and calculated an average, I get a certain number. If I take 2 of you at a time, get your average 2, get your average 2, get your average, and then I average all of those averages, will it be different? No, of course not. You're still all the same people. Yes? If I took 2 of you at a time, took your averages, and then averaged all those averages, of course it's still the same average. Why would it be any different? Why would it be higher or lower? There's no reason. Yes, sir.
Is that a good representation of the data?
How do you mean?
Like, it seems kind of misleading that you think that it'd be more average ages towards the middle, but that's just because of how the chart displays the rest of it. Like,
You mean this one?
is that not the top one? Well, because like the bottom is just like a bunch of different averages, but then like if you went to actually see those people, you wouldn't find a bunch of 40-year-old people. You'd find a bunch of 2 and 8-year-olds. Like, right?
That's what would happen most likely. Is it impossible to get a bunch of people from right there? No. It's not impossible, of course. If I take a random group of 10 people, could I get 10 people from right here?
But it's
Of
possible.
course I can. Why would it be impossible? Of course I can. That's why there's something here.
But could you get 10 40-year-olds?
Why not? I don't understand.
Well, the chart above says that there are none.
Oh, no. Okay, I see what you're talking about. All right, so you're saying this is, all right, let's say this is 40, just to give it a number.
Yeah.
You can't get 10 40-year-olds. Of course not. But you can get a mixture that has an average of that or close to that. Of course. In fact, that's the most likely thing to happen. Okay, I like it. That's sort of what the average means. And that's why we call the average the expected value. For a sample, what do I expect its average to be? The average of the population.
I guess what he's saying too also is that if you present the second graph, how do you notate that to say that there is no one at 40?
You don't. You don't care. What's this second graph represent?
The averages. Okay.
The averages of 10. That's what this means. It doesn't have to say shit about this graph. That's its own graph. So this doesn't care that there's no individuals because it's not showing individuals. It's showing groups of 10. So groups of 10.
And
That's
would
what
be
this
like-
represents.
In like the title of the graph, you're presenting it. You just basically say like, if you can't figure that out, that's on you. But here's what it is.
Of course, yeah. But this is just an idea we're exploring right now. Okay. Now, what the mean doesn't change. I hope to God everybody said yes, it does. But think about it, please. If I take the same numbers, if I take them one at a time, or if I take the numbers two at a time, why would that change the average? That doesn't make any sense. It's the same numbers. It's going to come out to the same average. I don't know. You guys don't believe me. What's the average of 1, 2, 3? 2. The average is 2. This is my little population, right? Now, if I take 2 at a time, what can I get? I get 1, 1, 1, 2, 1, 3. 2, 1, 2, 2, 2, 3. 3, 1, 3, 2, 3, 3. That's all the possible things with replacement. You guys did something like this with like a rolling die and stuff in the homework. What's the averages of each one? The average of this one is 1. The average of this one is 1.5. The average of this is 2. 1.5, 2, 2.5. If I average all those averages up, I am going to get 2. And if you don't believe, try it. Add these all up and divide by 9. Because there's 9 of them, aren't there? You'll get 2. In fact, what's the most occurring thing? What's the most likely thing here? 2. You can see you're going to get an average of 2 because for every 2.5, there's a 1.5. For every 3, there's a 1. So the average is going to be 2, isn't it? This is what I mean. Just because I take 2 of you at a time instead of 1 of you at a time, it's not going to change the average age. That'd be weird. 1 of you at a time, now I'm going to take 2 of you and everybody gets older. Oh, stop it, Jeff. Ugh, No, I don't have that kind of power. The average doesn't care how many I do at a time. So that stays exactly the same. The mean of the individuals stays the same as the mean of the samples. But what definitely changes? What's bigger here than here? I mean, what's the other thing we got to find? We got the mean. What's the other important thing? What's the other thing besides the mean? Standard deviation. Thank God. Right? We always got to figure out the mean and the standard deviation. Where's the standard deviation bigger?
Middle.
What middle? There's only 2 pictures up there. The top one. Doesn't this data get away from the mean more? So the standard deviation gets smaller. It goes towards the middle. And in fact, if I did n equal to 50, the picture would look like this. So the magic number for most distributions comes out to be greater than 30. Once you take a sample bigger than 30, you end up with something that's normal enough. So n greater than 30. Normal enough. Normal enough for what? I always mean normal enough to use the z-score chart. So look, the mean stays the same. The standard deviation becomes this. The standard deviation of the sample means becomes the old one divided by the square root of the sample size. The bigger the sample I take, the harder it is for them to be different from the middle. So if I took 2 of you at a time, is it impossible for me to get a sample that's got an average age of 40, right? If I took, including me, right? No. If I took 25 of you at a time, now it's going to be, really hard to get a sample of an average of 40, right? So the bigger the sample I take, the less likely it is for them to be further away from the mean. See how this became less spread out? And now it's even less spread out. If I took n equal to 500, it would be crazy. N equal to 500 would basically be like, wow, like really just crazy. Okay, so this is, now we're going to do some of this on Tuesday, obviously. And believe it or not, I got a handout. On Tuesday, we'll look at that first thing, and then the rest of the time will be devoted to review. But the only thing that changes, if I take a sample and then I ask, what's the probability that the sample would be greater than something? You don't divide by the old standard deviation, you divide by the new standard deviation. So the first thing you do when you see me taking a sample and asking about the sample means, you got to change the standard deviation. You can't use the one that's good for individuals. You got to find the one that's good for groups. That's what this is. All right, that's plenty. Wow. So Tuesday, we'll go back over some of this and do some examples. Everybody got a practice test, right?